Okay, we continue with section 15.3. This is video 2. I still have some more examples. Again, like you guys see, we're starting from something easy and then we're building more. Okay, so yes, they will be getting more challenge. So I start on example 3. I did only one with you guys. I'm going to solve example 3b. So let me just review. For each pair of expressions, find the least common denominator. And when we find the least common denominator, then convert each expression to equivalent fraction with the denominator equal to LCD. Okay, so let's do example B. So we have 5 over x minus 3. And we have the second rational expression, which is x over x plus 1. So first what we need to do, we need to find least common denominator of denominators which we have. This is easy case since x minus 3, our first denominator, is prime. So you cannot factor x minus 3, we're just going to keep x minus 3. The same thing, the second denominator, which is x plus 1, is prime also. There is no greatest common factor. So we're going to rewrite x plus 1 as x plus 1. So least common denominator of x minus 3 and x plus 1 is a product of both of them, since they both prime numbers, prime expressions. So it's going to be x minus 3 times x plus 1. So at least here we don't really have to do too much work. Okay, so we have that LCD. Second, what we're going to do, we need to create equivalent fraction with LCD as a denominator. Fractions, because we have two expressions. So this is what we're going to do. Take the first original fraction, which was 5 over x minus 3. Okay. What we want to do, we want to build equivalent fraction with denominator, which is your LCD. So we need x minus 3 times x plus 1. So look what happened. Our original fraction already has x minus 3. We already have x minus 3. The missing one is x plus 1. So we're going to multiply top and bottom of your original fraction by the missing factor. Okay, so we're missing x plus 1. So we're going to multiply top and bottom by the missing factor. And now, again, denominator is already ready for us. This is LCD, x minus 3 times x plus 1. Numerator will be 5 times x plus 1. So the last step, just simplify. So distribute that 5 to both. So you're getting 5x plus 5. Denominator, almost all the time, you keep it as a product of factors. So keep it as x minus 3 times x plus 1. So we built equivalent fraction. So 5 over x minus 3, which was our original rational expression, is the same as 5x plus 5 over x minus 3 times x plus 1. They are both equal, they are equivalent. Okay, now we're going to do the same thing with the second fraction. The second fraction is x over x plus 1. So we want to build equivalent fraction where the denominator is least common denominator, which is x minus 3 times x plus 1. So this is LCD. This is what we want to have on the bottom. So we're building equivalent fraction. So look what happened. Our original fraction has already x plus 1. We already have x plus 1. So the missing factor is x minus 3. So we're going to multiply top and bottom by the missing factor, which is x minus 3. So we're missing that x minus 3. Okay, so now we're building the equivalent fraction. So we're going to multiply numerators together. So x times x minus 3 and denominators together, which we already have it. That will become our LCD. Just simplify. You can distribute x, so that will give you, just put that better. That will give you x squared minus 3x over x minus 3 times x plus 1. Okay, so our second rational expression, which originally had form x over x plus 1, is equivalent to x squared minus 3x over x minus 3 times x plus 1. Okay, so they are equivalent. Okay. And I have 2 more examples. C. So we're doing the same thing. We have to find the LCD and then rewrite each original rational expression using the denominator from LCD. So the second example C, we have x over x squared minus 4. That's the first rational expression. And we have negative 3 over x squared minus x minus 2. Okay, so first find least common denominator of the first denominator, which is x squared minus 4 and x squared minus x minus 2. Okay, so let's go back. Okay, so how we find that least common denominator? We need to factor each denominator. So let's go back to those steps. I know it's a lot, okay? So we're taking that x squared minus 4. We need to factor this, rewrite this as x squared minus 2 squared. And you're going to use the formula, difference of square, which is the same as a minus b times a plus b. So rewrite that as x minus 2 times x plus 2. So we factor, so just save that, the first denominator. While we do that again, let's go back. We need to find the LCD. So next, take the second denominator, which is x squared minus x minus 2, and factor using AC method because it's quadratic. A it's 1, B it's -1, C it's equal -2. So A times C it's equal 1 times -2, which is -2. Find two numbers which by multiplication gives you A times C, and the same two numbers by addition gives you B, which is -1. So what's going to work here? -2 and +1. This is nice case, easy case, because A is equal 1. There is 1 in front of x squared. So to factor x squared minus x minus 2, this is the same as x plus first integer times x plus second integer. And let's save that. So now we're going back. We need to find LCD of x squared minus 4 and x squared minus x minus 2. So LCD will be, okay, and I'm repeating. So this is our denominators, okay, x squared minus 4 and x squared minus x minus 2. So let's check first the factors which repeats here. Both of them has x minus 2. So let's rewrite x minus 2. And they both are bring to the first power, okay, times, and now you multiply them by the unique factors, the one which don't repeat. So x squared minus 2, we still have x minus 2, so we need to multiply that by x minus 2. I'm sorry, x plus 2. And x squared minus x minus 2, the second denominator, has a factor x plus 1, which we didn't use, so we have to multiply that by x plus 1. Okay, so this is least common denominator. We have it. Now let's go back to the problem. Okay, so we find least common denominator. What also they want you to do in those problems? They want you to rewrite each original fractions with denominator from LCD. Okay, so let's do that. Next. Rewrite each original fraction with the denominator equal to LCD. Okay, so LCD is x minus 2 times x plus 2 times x plus 1. So, okay, let's go back. We can do it. The first fraction is x divided by x squared minus 4. So don't forget that we already factored that x squared minus 4. X squared minus 4 is the same as x minus 2 times x plus 2. So you want to rewrite that denominator as a product of factors. Okay, so now we're building equivalent fraction. This fraction we want to have LCD as a new denominator, which is x minus 2, x plus 2, and x plus 1. So how are we going to do it? Let's just notice that our original fraction already has x minus 2 and already has x plus 2. So to build that new denominator, we only missing x plus 1. So we're going to multiply top and bottom of original fraction by the missing factor from LCD, which is x plus 1. So like you see, we're not changing anything because technically you take your original fraction and you multiply by 1 because x plus 1 over x plus 1 is 1. So that will become numerator times numerator, so x times x plus 1. And denominator we just built will become your LCD. Okay, you can simplify that. Distribution property, so x times x is x squared, x times 1 is x. The denominator you keep as a LCD, which is the product of factors, of prime factors. So just rewrite that as x minus 2 times x plus 2 times x plus 1. We have it. Okay. So again, x over x squared minus 4 is equivalent to this. Okay. We're going to do exactly the same work. We're going to take the second original expression, which is negative 3 over x squared. Okay, so we're going back. And now we're taking the second original fraction, which is negative 3 over x squared minus x minus 2. X squared minus x minus 2. And we're going to rewrite this fraction using new denominator, which is least common divisor denominator. So we're creating equivalent fraction. Again, our new denominator is LCD, which is x minus 2 times x plus 2 times x plus 1. So to see that better, you want to rewrite this denominator, okay, which we had. Let's just rewrite that using the factors so we can see which factor we're missing. So let's just redo it. Negative 3 over x squared minus x minus 2. We factor that. X squared minus x minus 2 is the same as x minus 2 times x plus 1. Okay. So again, they are equivalent. Okay, just rewrite this denominator using factors. Okay, and we're building equivalent fraction. In denominator, we need product of x minus 2, x plus 2, x plus 1. So let's check what we have. Our original fraction has x minus 2 already, so we good. And our original fraction has a x plus 1, so we good here. So the only missing, so we're missing x plus 2. So take your original fraction, multiply top and bottom by the missing factor, which is x plus 2. And now we're going to multiply numerators together. So we have negative 3 times x plus 2. And denominator is ready, which is our LCD. You can do one extra step, which means distribute negative 3 to both. So that will be negative 3x minus 6 over x minus 2 times x plus 2 times x plus 1. Okay, so that will be, so the second original rational expression, which was negative 3 over x squared minus x minus 2, is equivalent, which means it's the same fraction as negative 3x minus 6 over x minus 2 times x plus 2 times x plus 1. Okay. And I have last example. Okay, one more. So that was C, D. We're still working on the same thing. We're finding LCD and we're building equivalent fractions when the denominator has to be LCD. Okay, so you have two rational expressions, 9 w minus 2, and the second rational expression is 11 2 minus w. Okay, so find least common denominator. Okay, so you have to be careful here. This is a little tricky. Here, the least common denominator is w minus 2. Okay, why? Because the second expression, the second rational expression, 11 over 2 minus w, should be rewrite by factoring negative 1 from the denominator. So here we have to just show that those two rational expressions, they have the same denominator. So what we're going to do, first, just to see that better, I'm going to switch the order and I'm going to put w first, since w has a negative sign in front, so I'm going to rewrite that as negative w, and 2 has no operation in front, that means that means it's positive. So this is the same as 11 over negative w plus 2. So our denominator still doesn't look the same like the denominator of the first fraction. The first fraction has w, we have negative w. The first fraction has negative 2, we have positive 2. So to make them the same, we're going to factor negative 1. So when you factor negative 1 from the denominator, we'll end up with w minus 2. Okay, and now what you're going to do with this negative 1, you can rewrite this fraction as negative 1 times 11 over w minus 2. And now you can multiply that negative 1 by numerator. So technically, you take negative 1 from denominator and you can move up to numerator. So that will become -1 times 11 over w minus 2, which is the same as -11 over w minus 2. So all that work which I show, I just go back. I want to just show you that 11 over 2 minus w is the same after we doing that simple operation, which means factoring -1 from the denominator. So this is equivalent to -11 over w minus 2. And now we don't need to do any work because both of them have the same denominator, which is w minus 2, which is our LCD. Okay, that's it. That was the last example from section 15.3. Now you guys ready to move on to Alex and start working on your objectives. Okay, thank you for watching the video.